Zoom session is being brought to you by the Fractal Crystal Ball. Okay. All right. There we go. Today we go through section 1.1 about the coordinate plane and section 1.2 about graphs of equations. All right. We start with the coordinate plane. The idea is that it's a two-dimensional plane in order that it can graph two numbers. A single line, a one-dimensional line, it's equivalent to a number. For each point on the line, there's a number. For each number, there's a point on the line. Here, there's a pair of numbers for each point on the plane. You start off by setting up two perpendicular lines called axes. This is the horizontal one, the x-axis. The vertical one is the y-axis. They're at right angles to each other. Once you've chosen those axes, you can give coordinates for any point on the plane. Given this point P, we drop these vertical perpendiculars and this horizontal perpendicular, and you get a rectangle, and the opposite sides are equal. So this side, call it x, this vertical distance, call it y, and x by y, those are the coordinates of the point P. On the x-axis, every point on the x-axis is where y equals 0. So these are the points of the form x by 0. On the y-axis, x is 0. So these are the points of the form 0 by y. These two lines divide the plane into four parts called quadrants. This upper right quadrant, plus by plus coordinates, is called quadrant 1. This upper left, minus by plus, is quadrant 2. This lower left, negative by negative, is quadrant 3. And this lower right, plus by minus, is quadrant 4. Now, okay, we're going to talk about points and points in the plane. Then you should be talking about geometric concepts. Here we'll discuss distances and midpoints. Given 2 points, what is the distance between them and what is the midpoint between them? Okay, we'll say that this point here is x1 by y1. This point here is x2 by y2. The subscripts are just to recycle letters. There are more than 26 unknown things in the universe. So, okay, given the distance, given these 2 points, what's the distance? Well, we draw this horizontal line with length x2 minus x1. It's the difference of the x coordinates. This vertical line has length y2 minus y1, the difference of the y coordinates. They meet at a right angle, and therefore we have the Pythagorean theorem involving x2 minus x1, y2 minus y1, and d. D squared is the sum of the squares of x2 minus x1 and y2 minus y1. Or, taking square roots, the distance d is the sum of the squares of the differences of the coordinates. That's 4 ofs in a row. Midpoint formula is pretty simple, actually. X1, Y1, X2, Y2, what's midpoint? Is it what by what? Well, the x coordinate for M is the average of the x coordinates, x1 plus x2 over 2. The y coordinate is the average of the y coordinates, y1 plus y2 over 2. The midpoint has average coordinates. So there's some examples from the book. Plot 0 by 5. Here it is, over 0 up 5, it's on the y-axis. Negative 1 by 0 is on the x-axis, back 1, negative 1 by 0. Negative 1 by negative 2 is down, back 1, down 2 here. And a half by 2/3 is over a half, up 2/3. Now here's the question about what's the midpoint of the distance between these points. Well, okay, they just graph these in the book, but we can see that this point here is back 3 and up 3, so it's negative 3 by 3. This point here is over 5 and down 3, so at 5 by negative 3. The midpoint, we take the average of negative 3 and 5 over 2. The y value 3 plus negative 3 over 2. After a small amount of work, it's at 1 by 0 here. The distance, well, we take square root of sum of squares of differences in coordinates. Minus 3 minus 5 here, 3 minus negative 3 here. This is -8, square that, plus 6, square that. All right, see, the square root of 64 plus 36 is square root of 100, which is 10. Now here they have plot -3 by -6, 4 by 18, -3 by -6 here, 4 by 18 here, on the midpoint and the distance between them. Okay, midpoint, -3 plus 4 over 2, -6 plus 18 over 2. That's 1/2 by 6. Distance, square root of sum of squares of differences. -3 minus 4 squared here, plus -6 minus 18 squared here. This is -7 squared plus -24 squared, square root. Square root of, here, this is a 49 plus this is 576. These add up to 625, which is a rational number, namely 25. So what we're getting here is what's called a 7, 24, 25 triangle. Same for 7 by 3 and 11 by 6. All right. So over 7 up 3, over 11 up 6. These are the points. Midpoint, it's the average of 7 by 11 over 2, 3 plus 6 over 2, which comes up to 9 by 4.5. The distance, square root of sum of squares of 7 minus 11 here, 3 minus 6 here. That's -4 squared plus -3 squared square root. Root of 16 plus 9 is root 25. Is a distance of 5. Okay. Here they're being a little bit more annoying. We're given 3 points: 3 by 1, -1 by 3, -1 by -1, P, Q, and R. Which of P and Q is closer to R? Well, all right, we just find the distance from P to R and Q to R. P to R, so square root of sum of 3 minus -1 squared plus 1 minus -1 squared, which, if you work it out, is root 20. For Q to R, the distance is -1 minus -1 squared plus 3 minus -1 squared. This cancels, you get the square root of 4 squared, root 16. And okay, of the two, root 16 is smaller than root 20, so Q is closer to R than P is to R. Now here they're being annoying. We have 4 points: -2 by 9, 4 by 6, 1 by 0, -5 by -5, 3 by 3. And they have to prove these are the corners of a square. Now, when you have a square, 4 of the sides are equal and the 2 diagonals are equal, and those 2 suffice to make it a square. So, all right, distance from A to B, work it out, it's root 45. Distance from B to C, work it out, it's root 45. Distance from C to D is, again, root 45. Distance from D to A, work it out, it's root 45. Distance from A to C comes out to root 90. Distance from B to D comes out to root 90. So you have 4 equal sides and equal diagonals. Therefore, it's a square.